Alright, continuing with that last version, we can take off the loop and it will continue on. This was member 12 we were playing with, now it's at member 13 and 14 and so on. Each of these is being seeded with two sets of chemicals initially distributed randomly. We can change what that initial size is, and so for example we can say start with 43 chemicals populated, and let's loop this, and you can see obviously there's quite a different effect taking place here. With that many random initial chemicals thrown into the system, we get much more pronounced behavior. Now we can do some other things. Effect is measuring, it's controlling how much single transfer of chemicals affects not only the indicated addresses but nearby addresses. So the bigger the effect, the more dispersed each transfer's behavior is. So if I change effect to 1, for example, and say set, we get a totally different behavior with much more localized actions taking place. And if we zoom in quite a bit vertically, we see there's really nothing in these tubes in between here, but something is apparently happening on the extreme ends of this. Mutation rate is used when we're playing with evolvability, and there's some evolvable code sitting in the system, but it's not fully plugged in right now. DT affects the time step, and that's a bit of a scary one to interact with because some of these constants are also hardwired in a few spots, but we could step forward by a smaller amount, and it slows down the simulation but presumably gives a more accurate presentation of the behavior also. And by looking at this, we can see if really coming down to an epsilon near 0 totally changes the behavior, or if it really is sort of converging on a behavior. Save was an attempt to be able to save the state of the system in a file, and load will read back a saved state. And when you save, it saves the current chemical contents in each bin. It saves the constants such as effect and DT, and it saves the genome if we're doing evolvable stuff. And then when you load, you can choose which of those to restore. Constant logging, I believe, was making a running log of everything that happens, and it's not really fit for human consumption. It's just a bare, almost a binary dump of each event that occurs that you would need to know about in order to replicate what the system's doing right now. It was made for saving this information just in case really interesting behavior occurred. I would write something to load those constants back in and be able to reproduce what I was seeing, but I never pursued that particular area, so that's an option. And you can turn on constant logging and it writes into a magic file, but it's not really used right now. Transfer addressing is an interesting button. So right now, based on the amount of source and destination in a tube, that tube specifies 2 tubes that should be connected. And the amount of source and destination actually are the address of the 2 tubes. If you turn on relative addressing, then those amounts are displacements from the current tube to the actual tubes that should be connected. And they tend to change the behavior of the system when you turn on relatives. So let's bring the number of tubes back down and let this system run. So here's a system that seems to be in some sort of semi-stable situation and is using absolute addressing. If I switch this to relative, you tend to see a lot of things change, and then the system sort of smooths out, which I guess makes sense because it tends to keep the action closer to the tubes that are actually specifying the transfers. I don't know, somehow it makes sense to me. And then if we go back to absolute, there's what you get. So we don't understand what the meaning of that is. This is a new member that just started, but there's something going on there. Snapshot was another option to make a recording of what was going on in the system, but that's poorly documented and rarely used at this point. So that's the basic setup. You can close this window if you like, and sometimes it slows things down to have that window open, and you can click anywhere to open it up again. if you close either the main display window or the control window, the whole system will exit at that point. And generally, it was built originally as a evolvable system. So once the member number hits 40, I believe, it'll do some sort of mating, mutating, and then go back to the original member. And then these buttons have less of an effect in some cases, because now it's working with evolved individuals and tracking their behavior. There's a fitness measure coming out here that's being used to choose which individuals survive and mate and become the creators of the next generation. But if you're just playing with individual members and you're just looping on a behavior and trying to see what they do, stick with the first generation and just play around with these things like throwing in stimuli and so on. But all the code is there, and it's ready to be modified and used for whatever you think might be interesting to look at. So have fun with it. Thanks.